Mr. Prabhakar Nilkant, Mr. Mukesh Dudhe, and Mr. Lalit Kumar Pawar. So I request the dignitaries to please come on the stage, on the dais. Mr. Sachin of introducing my guest panel members on the dais. Mr. Sachin Kulkarni is the founder and director of Avanza Systems. He has around 12 years of experience in corporate strategy, supply chain management, warehouse management, and manufacturing engineering. Founder of an award-winning supply chain technology and automation company. Experience in setting up greenfield and brownfield manufacturing operations. Broad industry exposure including automotive, auto components, industrial goods, metals and mining, rubber, polymers, and logistics. Experience with companies like Jaguar, Land Rover, Cummins, Gavale Holdings in India and United Kingdom. He is a mechanical engineer by qualification and did his Cardiff University, United Kingdom. Institute London, United Kingdom. He has done diploma in mechatronics and industrial automation from NTTF Darwin. So, on behalf of NTTF family, I welcome you for this panel discussions. Kindly applause. The second panel member, Mr. Prabhakar Nilkant, is experienced in product development and operations and training, people development, with a domain knowledge of product design and manufacturing for automotive, consumer, electronic products. Delivered many engineer designs to support product launches in South Korea, Dubai, Sterling for Norway. The products included electronics enclosures, rack systems, servo systems, chassis subsystems with EMC, EMI protection and IP54 proof design. Reduce the product development budget from 70% by introducing low-cost operations, production of retail equipments like point of sales and PCs. Received appreciation from HP for product design, DFM and DFX contribution, tooling qualification and supply chain management. Managed L&D, organizing training with training types of faculties, handled both internal and external trainings. Having training vendors completing over 4,300 hours of training to total in technical, soft skill, organizational, functional skills. Initial training repository, knowledge management, SME subject matter expert for organized skill matrix development. So on behalf of NTTF family, I welcome you today for today's panel discussion. Thank you, sir.
1, 2, 3.
The third panelist with us is Mr. Mukesh Dudhe, who is MBA in Production and Quality Management Systems from ISBM, Indian School of Business Management. Currently with ITW, 15 years in ITW work with production, operation, and now working as Head of Manufacturing Engineering for Auto India. Earlier with Render India in Production Department for 7 years. Special achievements, transform ITW India as an automated manufacturing unit from traditional manual manufacturing unit. So on behalf of NTTF family, welcome you for the panel discussions.
Yes, 1, 2, 3.
The fourth panelist is Mr. Lalit Kumar Pawar. He is a graduate in mechanical with honors in 1979. Postgraduate program in business management from Symbiosis Institute of Management Pune in 1982. Currently managing director of Pawar Metal Tech Private Limited. Implemented a project to manufacture high-tech copper titanium alloys and parts made therefrom. The company is the only manufacturer of this high-tech alloy on a commercial scale in the world. The alloy was developed in India by DRDO and is a unique contribution to the world of material science. Have held COMD positions in several reputed Indian companies, Tata Group, Escorts Limited, and multinational corporations like Jarvis B, Web, and American Axle and Manufacturing INC. Won several awards for innovation and technology, including the GS Pare MCCIA Award for Innovation and the SIDBI ET MSc National Award within the first 2 years of starting the project. Active participant at various industry and technology forums like CII, FICCI, IIM, ICTC, and MCCIA. 35 plus years of hands-on multidisciplinary experience of building, growing, and managing engineering, manufacturing, and high technology businesses. Very wide global exposure to engineering, manufacturing, and technology companies. Extensively traveled to USA, UK, Japan, Europe, Russia, Korea, Singapore, Sri Lanka, and other ASEAN countries. work with business managers from various cultures. So we are very happy to have you on our panel, sir. On behalf of NTTF family, I welcome you for this discussion.
NTTF 1, 2, 3.
See, the second panel discussion is more focused on the main oral subject, that is the mechatronics. And I have received some of the queries from trainees. The first question is, what are the challenges they face or we face that as a freshers in the company and entering into the automation area? And second question is classroom teaching subjects taught in the classrooms relevant to the industry requirements? This is the second question. And this is more focused on mechatronics, so you can start the panel discussion any sequence you want. Each can start. Just your viewpoint on the same, sir.
Am I audible?
Yeah.
Okay. With my experience in automating printer assemblies for Agro back in Singapore, one of the ecosystem that you all probably lack when you enter the industry is readily available components to build the entire system. Typically, the top 5 component you would require for building the system is sensors and servo motors and typical related small component, and some of the resistors and other electronic components which are not available readily for you to build a system. So whereas this is a typical situation in South Asia, so every time we have to get it done from North America and ship it from Europe, and we have to build the entire automation line. These are the challenges you might see when you start building your automation line, especially in mechatronics field. That's what I see. And a lot of cases we ended up customizing our sensors due to the requirement of cycle time and the production throughput. So our lead time went quite high during the implementation of automation line. So we lost our money businesses to China and Korea, because Chinese have been doing a lot of components themselves, custom and local made. So this is one challenge I see, that technically speaking, you see that ready-made components like subsystems, rails, and components are not available readily in India. If you are trying to implement automation here, even though a lot of companies like Japanese firms like Misumi and Kuka and all those people are coming out with a library of whole set of components, delivery time is where it matters a lot for us. So I think that's a challenge that I see as you move forward to start working in your companies wherever you go in mechatronics. That's about my technical advice I can give it to you.
Thank you, sir.
I would respond to those two specific questions a little differently. I think you asked what are the challenges young students would face when they go out into the industry, and what is the training and skills that they acquire, how are they helpful?
The classroom teaching, how relevant to the industry?
Yeah. So my response is this, that any education, and more particularly the engineering education, prepares you for the basics. And how you apply those basics that you have learned into any field that you go, whether it is manufacturing, whether it is design, whether it is quality assurance, how you apply those skills to the problem at hand is what makes the difference. And I think, having traveled all over the world, I think Indian engineers are, in terms of talent, capability, their learning curves are very sharp. So they are second to none. But I think more than the ability, it is the intent to apply themselves to a problem creatively that becomes a challenge. Most engineers tend to follow what has been done in the past, and I think the companies that they work in or the systems force them to work in that old-fashioned way. So my advice is that if you use the skills that you have acquired in the institute and apply them afresh to any problem that you face, you will get breakthroughs. And understand first, before you embark on solving an industrial problem or a problem on the job, think very carefully of what the goal is. Because many times in industrial environments, certain companies work in a particular way, and almost the whole industry thinks in that. So you take a problem to anyone in that industry and they will give you the same solution, that this can be done, this cannot be done. And I think that's where the problems are, and people get stuck. Technologies are moving at a very, very high pace, and Indian engineers are very well equipped. We are one of those countries where we have the optimum combination of hardware and design skills along with skills and competencies in electronics and software. And mechatronics is all about mechanical systems and electronics and controls, putting them together in an optimum way. But you don't find that combination in many countries, except, say, for example, the US. Not many companies in other parts of the world, including, say, countries like Germany or Japan, which are considered to be developed, have these competencies in the balance that it is required to produce an optimum automation solution or a mechatronic solution. So my advice to you would be, define your goal and then apply the skills that you have acquired. Look around, learn from the internet. Now information is available, and if you just go back to basics and put the elements together, you will get breakthroughs in automation, which are far more efficient and cost effective than anything that can be produced or has been produced in the past in the world. So that's my advice.
Thank you, sir.
As he said, I think recently what they have done is the evolution of education such that, unlike what we have in India, there are typical graduation or diploma in mechanical engineering or tool and die making, or now with NTTF mechatronics and IoT and so on, and or maybe bachelor degrees in electronics and electrical. But then if you look at alignment of education so far, so good, the last 30 years, they are more focused to either too much onto mechanical or too much into electronics and electrical, or we could be more domain oriented like chemical or civil, whatever. Looking at evolution, some of the European countries like Lithuania, Estonia, which is one of the topmost e-governance country in North Europe, where we have traveled sometimes and understand the education system, especially Finland. They have completely removed something called bachelor degree in mechanical or bachelor degree in electrical or electronics, or even for the matter, electronics and telecommunication. What they have done is, they understand the industry cycle, industry requirement, the core subject needed for the functioning of whether it's a mechanical system or electromechanical system or completely electrical system. So the olden technologies where it used to be pure mechanical oriented, they have removed those subjects. They have added, just like how Mr. Venugopal talked about, deletion, addition of new technologies in the system, what NTTF practice now, which is really wonderful initiative. So they call something called Bachelor of Engineering in Integrated Engineering. The meaning of this is they partially connect some of the electronic stuff, IoT stuff in the software. At the same time, they connect part of mechanical in the first 1 or 2 years. So by the end, you graduate for 4 years of engineering in Estonia, which is called integrated engineering. You would probably strip out entire machine as BMC machine or CNC machine yourself. You would address the problems related to electrical, electronic. At the same time, you would also solve the problems related to mechanical. This is what they call 100% aligned to industry alignment of education. So these are the challenges, and looking at these northern European countries, many universities are also changing their curriculum and content. And I guess probably, if you look at it, IIT never used to have BE mechatronics, if you look at it. They always used to have something streamlined, mechanical, electrical, or general subjects. It was only now, I think one of the IITs, Kharagpur, I believe, has only mechatronics. Other than that, none of the IITs have this mechatronics for now. So the challenge is, how could you adapt your mechanical strength and electronic strength and then match that skill to the existing ecosystem in the industry and wisely adapt into your problem that you define and then solve it on the spot. So awareness of the system, ecosystem is very important. You need to spend a lot of time doing research on the ecosystem of components, assemblies, or next solution that are available, either it be in India or overseas, and then use it wisely for your problem statement.
Yeah.
So, as I heard on the same problem, like many times we'll see like we have a lot of like experts inside the electronics or PLC side and same like mechanical and PLC. But the combination of to be get together and to resolve the problem will be quite difficult and also require a lot of skills. So rightly I said what are the implemented in the automation sector. So I feel like automation sector or mechatronics like where you can only learn by failures. So we should have to be first ready for the failures, and what are the failures comes again as every team says PDCA cycles. We have to do the PDCAs and applying all mechanical, pneumatic, electric and PLC knowledge. We have to be resolved on this one. Second, that's a real challenge in India. Everything for input as an automation is coming from the outside, and due to that outside contents, the skill factors are very less, and we are not easily get the trained people here, and also the skilled people who can upgrade our knowledges. So that's through internet or through teachings or traveling. We can learn a lot of things in the automations. That's how I will tell them, like we have to be learn through failures.
Thank you, sir.
So, good afternoon. So let me give my perspective as somebody who's actually studied mechatronics at NTTF. In fact, my principal is right here, so I was quite glad to see him this morning. What I'm going to say, some people may not like, and maybe a rather controversial statement to make. I have always believed that as mechatronics individual, we are basically jugaad artists, right? We have the ability to look at a problem in a different way, look at what is available and try to fix that problem. I have always applied that jugaad mindset to every problem I've solved, whether I've done multi-million-dollar greenfield projects in India or I've done any projects in any part of the world. So my first advice or recommendation to you would be to always think of yourself like a jugaad artist who's going to get put into probably a difficult situation and believe in yourself that you have the skills to fix those. Right? That's the first part. Secondly, the other approach that I've always had, which has worked for me, again something that horrifies my friends from the academic world, is an approach where I say first shoot, then try to aim, right? Because a lot of times you spend a lot of time trying to aim so hard that the objective is already passed. The time for it is already passed. So my objective would be first shoot, that will give you a good indication of how far away you are from your target and whether it's even worth your while to continue to go after that target. Right? So those are two things I would share based on my experience. The downside of taking this approach is that you're probably going to fail. And when you fail, you probably might fail very spectacularly, but don't worry about it too much. Just go out there, have an open mind, learn whatever you can, and try to fix problems. And again, like I said, very controversially, wherever possible, don't try and have any respect for the rules. Right? So break the rules so that you can actually set new ones.
Yes. Thank you, sir. Thanks to all the panel members for sharing their views on this particular two questions. I hope a lot of enlightenment has, I can see their faces sitting in the front. Yeah.
Can audience ask question?
Yeah, please.
Okay.
Yeah.
Since the discussion is becoming more academic oriented and all,
Yeah.
so I have not done BE mechanical like many of us, and I am proud to be an tool and die maker or blacksmith. I have heard or I have seen that lot of subjects are taught in first 2 semesters, and then you come down to the core trade what you are doing. Okay, if you reverse it, can it solve some of these problems?
Yeah, the question, if I can frame it properly, the syllabus what we maintain as of now we start with a lot of basic inputs giving there, and maybe somewhere in second year we start giving the real core area.
So sorry, I didn't mean to say that. I meant to say that in first year, no matter you are in textile engineer, you are electrical engineer, cement, polymer technology and all, they study chemicals, they study electrical, electronics, they study engineering, graphics and many other things.
Like general engineering.
Yeah, more of in general engineering. So can this subject be taught in last semester, so that when you become an engineer, the complete engineer perspective is embedded there?
Yeah. So I think any one of the panelists can we have time for one panelist.
Okay, so just to address that question, right? A lot of people in India do engineering because that is what the peer group is doing, right? So that's the reality of it. I had a friend of mine who studied with me at college. After the first year, he took a couple of years off, right? So he didn't come back to university. The reason he took a couple of years off is purely because he loved thermodynamics. So he went away and just did experiments on thermodynamics for 2 years. Now, a lot of Indian institutions, in the traditional sense, don't give you that independence and flexibility. So when he came back, he graduated mechanical engineering. Somehow he graduated, right? The only thing he was good at was basically thermodynamics. So that guy actually is one of the chief designers of the internal combustion technology at the R&D Center for Mercedes. Now the point is, the education system of which he was a part gave him the independence to experiment, which unfortunately doesn't happen in India. So if somebody gets a break, right, or somebody has a year off, it's as good as his academic career is finished. And that is the reason why they have to set up that the first year is basically an aid in helping the students realize exactly what you want to do going forward. A lot of people change their streams after the first year. So maybe that's the reason why the structure is the way it is in India, which is a combination of the entire ecosystem and the way it is perhaps. I don't know if that answers your question or addresses some of those points, but that's my personal opinion.
Yeah, thank you, sir.
I would just go 180 degrees opposite to the recommendation that you made. In fact, the way the engineering education is right now, 4 years program, it's very, very specialized. So you enter and you know that you've got to take mechanical engineering and or production engineering. There are sub-specializations within those, or mechatronics now. During the time that I did engineering, we had a 5-year course, and the first 2 years were general. And though I graduated as a mechanical engineer, I've done a full course in civil engineering, a full course in electrical, a full course in electronics in my second year. So I think that foundation is important for you to build whichever stream you want to take. And engineering is an interdisciplinary, no matter how narrowly we might try to define it, it's an interdisciplinary science. So you've got to have the foundation of all the branches of engineering, particularly the core branches, if you want to become a successful engineer in any field of engineering. So I would very strongly recommend that you broad base the initial 2 years and then have 2 years of specialization.
Yeah, thank you, sir. And we are closing this panel discussion. I thank all the panel members to be part of this on behalf of NTTF family and NTTF Alumni Association Pune. Thank you, sir. Please take your seats. Please clear the chairs. The next presentation by team 4. Get ready. Do your setup, please. We'll have the 4th presentation of this competition. 4th and the last presentation of the quality survey competition. Please set up your project, and once you are ready, please inform me.
Hello.
Efficient and cost effective, and anything that can be produced or has been produced in the past in the world. So that's my advice.
Thank you, sir.
As he said, I think recently what they have done is the evolution of education such that unlike what we have in India, there are typical graduation or diploma in mechanical engineering or tool and die making, or now with NTTF mechatronics and IoT and so on, and or maybe bachelor degrees in electronics and electrical. But then if you look at alignment of education so far, so good, the last 30 years, they are more focused to either too much onto mechanical or too much into electronics and electrical, or we could be more domain oriented like chemical or civil, whatever. Looking at evolution, some of the European countries like Lithuania, Estonia, which is one of the topmost e-governance country in North Europe, where we have traveled sometimes and understand the education system, especially Finland. They have completely removed something called bachelor degree in mechanical or bachelor degree in electrical or electronics, or even for the matter, electronics and telecommunication. What they have done is, they understand the industry cycle, industry requirement, the core subject needed for the functioning of whether it's a mechanical system or electromechanical system or completely electrical system. So the older technologies where it used to be pure mechanical oriented, they have removed those subjects. They have added, just like how Mr. Venugopal talked about, deletion, addition of new technologies in the system, what NTTF practice now, which is really wonderful initiative. So they call something called Bachelor of Engineering in Integrated Engineering. The meaning of this is they partially connect some of the electronic stuff, IoT stuff in the software. At the same time, they connect part of mechanical in the first 1 or 2 years. So by the end, you graduate for 4 years of engineering in Estonia, which is called integrated engineering. You would probably strip out entire machine as VMC machine or CNC machine yourself. You would address the problems related to electrical, electronic. At the same time, you would also solve the problems related to mechanical. This is what they call 100% aligned to industry alignment of education. So these are the challenges, and looking at these northern European countries, many universities are also changing their curriculum and content. And I guess probably, if you look at it, IIT never used to have BE mechatronics, if you look at it. They always used to have something streamlined, mechanical, electrical, or general subjects. It was only now, I think one of the IITs, Kharagpur, I believe, has only mechatronics. Other than that, none of the IITs have this mechatronics for now. So the challenge is, how could you adapt your mechanical strength and electronic strength and then match that skill to the existing ecosystem in the industry and wisely adapt into your problem that you define and then solve it on the spot. So awareness of the system, ecosystem is very important. You need to spend a lot of time doing research on the ecosystem of components, assemblies, or next solution that are available, either it be in India or overseas, and then use it wisely for your problem statement.
Yeah. So, as I heard on the same problem, like many times we'll see like we have a lot of like experts inside the electronics or PLC side and same like mechanical and PLC. But the combination of to be get together and to resolve the problem will be quite difficult and also require a lot of skills. So rightly I said what are the implemented in the automation sector. So I feel like automation sector or mechatronics is like where you can only learn by failures. So we should have to be first ready for the failures, and what are the failures comes again as every team says, PDCA cycles. We have to do the PDCAs and applying all mechanical, pneumatic, electric and PLC knowledge. We have to be resolved on this one. Second, that's a real challenge in India. Real everything for input as the automation is coming from the outside, and due to that outside contents, the skill factors are very less, and we are not easily get the trained people here, and also the skilled people who can upgrade our knowledges. So that's through internet or through teachings or traveling. We can learn a lot of things in the automations. That's how I will tell them, like we have to be learn through failures.
Thank you, sir.
So, good afternoon. So let me give my perspective as somebody who's actually studied mechatronics at NTTF. In fact, my principal is right here, so I was quite glad to see him this morning. What I'm going to say, some people may not like, and maybe a rather controversial statement to make. I have always believed that as mechatronics individual, we are basically jugaad artists, right? We have the ability to look at a problem in a different way, look at what is available and try to fix that problem. I have always applied that jugaad mindset to every problem I've solved, whether I've done multi-million-dollar greenfield projects in India or I've done any projects in any part of the world. So my first advice or recommendation to you would be to always think of yourself like a jugaad artist who's going to get put into probably a difficult situation and believe in yourself that you have the skills to fix those. Right? That's the first part. Secondly, the other approach that I've always had, which has worked for me, again something that horrifies my friends from the academic world, is an approach where I say first shoot, then try to aim, right? Because a lot of times you spend a lot of time trying to aim so hard that the objective is already passed. The time for it is already passed. So my objective would be first shoot, that will give you a good indication of how far away you are from your target and whether it's even worth your while to continue to go after that target. Right? So those are two things I would share based on my experience. The downside of taking this approach is that you're probably going to fail. And when you fail, you probably might fail very spectacularly, but don't worry about it too much. Just go out there, have an open mind, learn whatever you can, and try to fix problems. And again, like I said, very controversially, wherever possible, don't try and have any respect for the rules. Right? So break the rules so that you can actually set new ones.
Yes, thank you, sir. Thanks to all the panel members for sharing their views on this particular two questions. I hope a lot of enlightenment has, I can see their faces sitting in the front. Yeah.
Can audience ask question?
Yeah, please.
Okay.
Yeah.
Since the discussion is becoming more academic oriented and all,
Yeah.
so I have not done PE mechanical like many of us, and I am proud to be an tool and die maker or blacksmith. I have heard or I have seen that lot of subjects are taught in first 2 semesters, and then you come down to the core trade what you are doing. Okay, if you reverse it, can it solve some of this problem?
Yeah, the question, if I can frame it properly, the syllabus what we maintain as of now, we start with a lot of basic inputs giving there, and maybe somewhere in second year we start giving the real core area.
So sorry, I didn't mean to say that. I meant to say that in first year, no matter you are in textile engineer, you are electrical engineer, cement, polymer technology and all, they study chemicals, they study electrical, electronics, they study engineering, graphics and many other things.
General engineering.
Yeah, more of in general engineering. So can this subject be taught in last semester, so that when you become an engineer, the complete engineer perspective is embedded there?
Yeah. So I think any one of the panelists can, we have time for one panelist.
Okay, so just to address that question, right? A lot of people in India do engineering because that is what the peer group is doing, right? So that's the reality of it. I had a friend of mine who studied with me at college. After the first year, he took a couple of years off, right? So he didn't come back to university. The reason he took a couple of years off is purely because he loved thermodynamics. So he went away and just did experiments on thermodynamics for 2 years. Now, a lot of Indian institutions, in the traditional sense, don't give you that independence and flexibility. So when he came back, he graduated mechanical engineering. Somehow he graduated, right? The only thing he was good at was basically thermodynamics. So that guy actually is one of the chief designers of the internal combustion technology at the R&D center for Mercedes. Now the point is, the education system of which he was a part gave him the independence to experiment, which unfortunately doesn't happen in India. So if somebody gets a break, right, or somebody has a year off, it's as good as his academic career is finished. And that is the reason why they have to set up that the first year is basically an aid in helping the students realize exactly what you want to do going forward. A lot of people change their streams after the first year. So maybe that's the reason why the structure is the way it is in India, which is a combination of the entire ecosystem and the way it is perhaps. I don't know if that answers your question or addresses some of those points, but that's my personal opinion.
Yeah, thank you, sir.
I would just go 180 degrees opposite to the recommendation that you made. In fact, the way the engineering education is right now, 4 years program, it's very specialized. So you enter and you know that you've got to take mechanical engineering or production engineering. There are sub-specializations within those, or mechatronics now. During the time that I did engineering, we had a 5-year course, and the first 2 years were general. And though I graduated as a mechanical engineer, I've done a full course in civil engineering, a full course in electrical, a full course in electronics in my second year. So I think that foundation is important for you to build whichever stream you want to take. And engineering is an interdisciplinary, no matter how narrowly we might try to define it, it's an interdisciplinary science. So you've got to have the foundation of all the branches of engineering, particularly the core branches, if you want to become a successful engineer in any field of engineering. So I would very strongly recommend that you broad base the initial 2 years and then have 2 years of specialization.
Yeah, thank you, sir. And we are closing this panel discussion. I thank all the panel members to be part of this on behalf of NTTF family and NTTF Alumni Association Pune. Thank you, sir. Please take your seats.
1, 2, 3.
Volunteers, please clear the chairs. The next presentation by team 4. Get ready. Do your setup, please. We'll have the 4th presentation of this competition. 4th and the last presentation of the quality survey competition. Please set up your project, and once you are ready, please inform me.
Good morning to jury members and other members. Welcome. We, the achievers, are here to present the QC presentation of our MNT Center. This is our center's profile.
N2 Technical Training Center is one of the technical institutes in India.
This center started in 2010 in the collaboration of Technova India Limited.
This is our registration letter. About us, the achiever is the quality circle team of MNTC, which is created to achieve more than average. Our motto:
Change is the real game.
Our team:
Yasser, the leader;
Akash Paul, the deputy leader;
Sahid Singh, active member;
Upendra Pal, active member;
our pillars, Mr. Joby Paul, unit head;
Mr. Deepak was the coordinator;
Mr. Nitin Matthew, facilitator.
This is our QC statistics. Team formed on 23rd Jan 2019. Number of meeting conducted 13.
Attendance and conductance 100%.
They had a venue of meeting every Thursday in VCS room.
Major problem focus: errors while checking dimensions. Problem solving methodology to a step of quality circle.
Solution of problem to implement new circuit.
Remark, problem solved.
This is our Gantt chart.
12-step methodology to solve QC problems. They are:
First one, identification of problem.
Second, selection of problem. Third, define the problem.
fourth, analyze the problem;
Fifth, identification of causes.
6, finding out the root causes. 7, data analysis.
8, developing solution;
9, forcing probability resistance.
10, trial implementation. 11, regular implementation.
12, follow-up and review.
This is PDCA cycle and it is also known as the Deming's wheel. PDCA stands for P plan, and under plan this is 3 steps: identification of problems, selection of problems, and define the problem.
Second, D. D stands for do, and under that, analyze the problem, identification of causes, finding out the root causes, data analysis, and developing solution. C. Check. Under check, trial implementation and forcible probable resistance.
A, under it, follow-up and review and regular implementation.
Step 1. Identification of problem. Tools and techniques used, brainstorming and data collection.
Using brainstorming method, we have listed out over 60 problems in our surrounding, and they are wastage of food, wastage of water,
loose grills and so on.
Step 2. Selection of problem. Tools and techniques used, ranking, analysis and brainstorming.
After listing out the problems, we have categorized them into 3 types. They are category A, problem solved by a QCD. Category B, problem solved with the help of core department.
Category C, problem solved with the help of management.
These are category A problems like absence of equipment in machine lab and no IC testers. These are B category problems like old books in library and old software in computer.
These are category C problems like no fire extinguisher in hostel and no Wi-Fi connectivity.
After application analysis, problems under category A are 10, problems under category B are 23, and problems under category C are 27. This is a pie chart shows the percentage of our problem. This is a decision matrix. We are listed about 10 problems and giving them a rating on the basis of quality, cost, delivery, safety, and productivity. And result are.
After the decision matrix, we have listed out the top 5 problems and given them individual rating according to quality, cost, safety, productivity, and problem 1, no proper output in labs.
Problem 2, improper timing of silent.
Problem 3, absence of zero testers in labs.
Problem 4, errors while checking dimensions. Problem 5, leakage of coolant in machines. After giving individual ratings to each of the problems, we found that errors while checking dimensions have been given the highest ratings. Step 3, defining the problem, tools and techniques, for WNH analysis and brainstorming.
What is the problem?
During manual inspection, there may be some errors like calibration error, environmental errors, which may cause wrong result in inspecting the workpiece.
Where is the problem occurring? At the final stage of inspection of components and workpiece.
When does it occur?
We collected the data from a QAD lab after QAD lab and found that problem will occur in one day irrespective of shift.
Who is being affected? Due to this problem, trainees have been affected, which ultimately affect their performance. Loss of time and management is also been affected.
How problem is occur?
When the workpiece are sent to the final inspection, error caused due to environmental factors, human errors. To avoid this problem counters, measures have to be done which stops the inspection.
Here is the flowchart. So the manufacturing process starts with exercise and drawing sketch.
After exercise and drawing sketch, raw material received from store and go for inspection. If raw material is okay, it will proceed. If raw material is not okay, it will go again to the source from received.
If the workpiece is accepted by the inspection, it goes to clamping and machining. After machining, it will declamp and going for the manual inspection. If it is okay, finish the piece part. If it is not okay, cycle repeats of clamping and machining.
Instrument human error can also be occurred. Manual error can be occurred while checking manual condition.
Define the problem or objective. To eliminate the errors caused by measuring instruments.
The affected areas are workshop, QAD labs, and tool rooms. Impact, increase in errors,
Reduction in production.
Increase risk of elimination.
goal setting. We have set goals for our project that are from 89 errors to 0 errors and time required that is 50 hours to 5 hours. Step 4. Analyze of problem. Tools and techniques used, brainstorming and check sheet. This chart shows the data collection of errors and time required for each workpiece of a week. The overall error while measuring workpieces were 13. It requires 3 to 5 minutes for measuring one workpiece.
Here is the check sheet of time duration of 1 week. Total error are 89.
Step 5. Identification of causes, tools and techniques, Ishikawa diagram and brainstorming. These are the list of causes for Ishikawa diagram.
After listing out the causes, we have made 4 classes for them, and they are:
First, man, work distribution and carelessness.
second is method, for that no calibration of equipment, manual method and 4 errors. Third, material, for that tolerance required and damage of components.
Fourth, machine, under machine, frequent calibration and no accurate output.
This is the Ishikawa diagram. It is invented by Mr. Kaoru Ishikawa and it is also known as a fishbone diagram, herringbone diagram and cause and effect diagram.
Step 6, root cause analysis, tools and techniques used, brainstorming. These chart shows whether the causes in the areas are present or not, and they are time consuming, yes.
Frequent calibration,
Yes. No proper maintenance.
No. More errors, yes. Carelessness,
yes. Work distribution,
no.
Manual method.
yes.
Analysis for finding the root causes. Why analysis? Cause 1, more errors.
Why?
No proper instruments.
Why? Due to wear and tear.
Why?
Mishandling.
Why? No proper training. Cause 2, time consuming. Why?
Due to slow method of measurement.
Why?
Manual method. Step 7, data analysis, tools and techniques used, pattern chart and brainstorming.
Here is the rating shows the individual problem of each causes.
This is a data collected for our causes and total defects are 30 and manual method got a highest occurrence of 26.6%, more errors 23.3%, time consuming 20%, carelessness 16.7%, and frequent calibration 13.4%.
After stratification of data, we obtain this Pareto chart, which shows that manual method has been given the highest rating. The red line is Lawrence curve, which shows the cumulative of each of the problem. Step 8, developing solution. Tools and technique used, brainstorming.
The root cause of our problem is manual method.
Solution to an automatic measuring system.
Advantage: no need to worry about checking each workpiece. Rate of checking is fast and reduce manual.
Disadvantage is its need break and less time period.
Is it accepted?
Yes.
This is a circuit diagram of our project. This is a Raspberry Pi module which is like a small computer. It processes the camera and camera is capture the image of our object or workpiece and it give to the processor. Processor is process it give to the display board. Display board digitally show the length and width of our object or workpiece digitally and it have accuracy of a 6 digit.
Step 9, forcing probable resistance. Tools and technique used, data collection.
Resistance from supervisor is about alignment.
Solution: we will make ensure the proper body has to be aligned for our circuit.
What about wear and tear?
As there are no moving parts in the project, there is no worry about wear and tear. It only needs rest time period.
Resistance from management is about permission.
We will ensure the benefits of our circuit to the management.
Step 10, try implementation and check performance. Tools and technique use, data collection.
This chart shows where we have implemented our project and they are workshops and lab.
Activity done used to measure dimensions. Here is the approval letter for our trial implementation.
Reduction in error. The time duration, the information collected of time duration of 9 Feb 2019 to 7 April 2019. Affected area is workshop. Before implementing our project, there are 89 errors. 3 minutes per workpiece. After implementing our project, 1 minute per workpiece.
This is after implementation data collection and we got the 3 main problems. First one is the carelessness.
Before implementation, there were increase in errors.
After implementation, decrease in errors.
It is accepted?
Yes.
Second, time consumption.
Before implementation, more time was needed to check each workpiece.
After implementation, it reduces to 70%.
It is accepted?
Yes. Third is manual method. Before implementation, we used to check each workpiece manually.
After implementation, no manual method needed.
It is accepted?
Yes.
Our objective and goal. Our goal to reduce the errors, time consumption and increase productivity.
What we achieved? We reduced the errors, we reduced the time consumption by 70% and we increased productivity.
Step 11, regular implementation. Tools and techniques, data collection, stratification. Here is approval letter for regular implementation.
Here is the data after implementing our project.
This is the estimated cost of our project. In our project, we are using Raspberry Pi, camera, LED strips and acrylic strips. The total cost of our project is 3,000 rupees.
Prevention for future. After implementing our project, we have made this chart to regularly check our project for any misalignment or any short circuit. After all, prevention is better than cure.
Here is our milestone chart after completion. Step 12, follow up and review tools and technique use, data collection.
Review. After implementing our project, we got very good feedback from staff, students and management. Here is the feedback of students.
Our benefits. It is easy to use.
It is automatic.
Reduces human effort.
Increase of productivity time.
Tangible benefits. Inspection rate has been increased by 45%.
Rate of checking each workpiece has decreased from 5 minutes per workpiece to 1 minute per workpiece.
Time consuming decreased by 70%.
Saving money from buying a CMM worth of 1 lakh.
Intangible benefits. Helps in building healthy relationship.
Personal development.
Job satisfaction.
Moral and confidence improve.
QC movement has been strengthened.
Tools and technique used in presentation.
Saving cycle.
Milestone and Gantt chart.
Flow diagram.
Check sheet.
Brainstorming.
4W1H method.
Stratification.
Cause and effect diagram.
Pareto analysis.
Graphs.
Viva analysis.
Conclusion. We the achievers have successfully implemented a solution to our targeted problem.
As a QC the cycle of enhancement, we always commit to hunt down the problem and solve them in a professional way.
Our next project. We are working on our next project that students not with the machine utilization chart.
Now time for the live demonstration. Here we can see that the project is powered by Raspberry Pi, which is the language is Python interpreter. Here we have kept an object that is the key. It shows the length and width of the object, that is now 21.5 97, that is the width of the object, and 49.83, that is the length of the object. It shows accurate measurement up to 6 decimals. That is same result as we get in CMM, that is coordinate measuring machines. We can save it. We can save up to 1 lakh or 2 lakhs rupees by just constructing a 3,000 rupees project. Thank you.
Good concept. I have few queries. So you said you can measure length and width.
Yes.
Can it measure diameter also?
Yes.
So that hole in the key,
Yes.
that can be also measured?
Yes. It works on edge detection. Wherever there is an edge, it can detect it and it can measure the edges from 1.1.
Okay, the second question is, can it detect, it is 2D camera?
Yeah.
Okay, so what about 3D type of dimensions? Like suppose that width, key has, suppose for example, normally key has equal width. Suppose on left hand side it has less width and on the right hand side it has more width.
Yeah.
So how it will detect?
Now we are using this as a 2D, as you said. If we change the camera to 3D and change the perspective of looking at the object, we can get the width, length and height of the object. We just need to change the camera and some few changes in the program.
Okay, that can be modified
Yes.
to that level.
Yeah.
And one more question. How it can judge whether that particular thing that, suppose that the surface is not flat, so suppose it is inclined, slant,
Yeah.
so it will not take the correct dimension, it will just be the projection of that particular image, so which will be, the measured dimension will be less than the actual dimension. So how you account for that particular?
This project works on pixel metric. It checks that how many mm is there in that pixel, which the camera is going on. If there is a slight, even a slight means taper or anything there, it will give accurate. If there is a 1 mm or 2 mm that taper, then it will give little means change in the output.
Suppose it is like this,
Yeah.
so it will detect this point and this point.
Yeah.
So definitely this length will be actually less than the actual length.
No, it won't be because it is from the top. And,
Yeah, that's what I'm saying.
yeah, even if you see like this, it is from the top, the edges don't matter. The initial point and final point will be at the same point now. So the edges don't matter. If you take a means normally the places the mount where we mount they are not in a much tapered. They are in just 1 mm or 2 mm that slightly.
Okay, the table is flat, but my job is like this. My object is having a taper.
Yeah, then it will affect the edge.
Okay. My second question was on slide number 44.
44.
Sorry. Where this calibration, I think it's next slide or this earlier slide. Yeah, this is, sorry, 43. Here, you have mentioned the cause as no calibration in the method. Okay, and in machine you have mentioned frequent calibration. So how frequent calibration could be a cause? Frequent calibration, in fact it is good, no?
Yeah.
If it is calibrated frequently, then it is a good point. How it can be a cause for the problem? Calibration means I am actually checking it frequently, whether there is any error or
So
not.
if machine checks frequently,
Yeah.
then it's good.
It's a good point. So it cannot be a cause for the
It cannot
problem.
be a cause for the problem.
Even in the final list of causes, you have actually selected it as a valid cause. After validation, go to 3-4 slides ahead. Yeah, frequent calibration.
Here we are saying no calibration.
It's the first one, and then frequent calibration. Actually, both are contradictory and both are valid causes. So, can you explain this one? No calibration I can understand, because of that the problem can occur.
But frequent calibration, last but one.
Okay. And my third question, okay, I am asking too many questions, but my third, this environmental errors, you said environmental, because of environmental factors, that, so how those factors are actually considered? You mentioned somewhere the machine stops wherever there is any error. Machine stops wherever there is any error. That's
We have mentioned the environmental errors.
go to the earlier slide, environmental, even in the title or selection of problem also you have.
Yeah, we made it when the machine, when the workpiece is being processed, environmental errors can be caused to means lengthen its width or by temperature and which.
So how your solution, how your this project takes care of those particular factors?
Now means when you check manually, the temperature causes the increase or decrease in length of metal. So if you check it by manual method, it won't be that accurate. But if you check with this, it would be up to 6 decimals. That you can see what is that increase in length or width of the object through environmental errors.
Thank you.
Thank you.